Please. Okay.
All right, hi, I think we're live now. So hi everybody, welcome to Codementor Office Hours. Yeah, so this is Wei Ting, I'm the founder of Codementor. Today we're very excited to have our Codementor expert mentor Jerome with us. So Jerome is a WebGL expert and a hardcore JavaScript developer. And today he's going to show us how to create an HTML5 game in WebGL and Three.js in an hour. Yeah, so because we like to make this as interactive as possible. So yeah, in addition to having Jerome demonstrating for us, let's also have an interactive discussion as we move along. So Jerome, please go ahead.
Okay, so let's start. Just one thing, guys, for all the spectators, let's say, if you don't want to talk or if you don't explicitly talk, please cut off your microphone. This way, all the audience will not hear all the back sounds that you have in the back, something like TV or stuff like that. So you put yourself on the mute, except if you want to talk, and you're welcome to talk, guys. But this way, I don't hear the street close to your house or something like that. Okay, so let's start. I share my screen. You are supposed to share a wonderful weird effect. And now you are supposed to see my screen. Please, somebody confirm that you are seeing my screen.
See it.
See it.
Excellent. Okay. So this is Flying Spaceship, a mini game in 3D with HTML5. This is going to be a live coding session. We're going to do it live together. And the slides are online. I'm going to forward, let me forward that to you right now, by the way. Youppies. Yes, I can pass, and I did. So I just pasted the link for all the slides that you can follow. There is a lot of links that's going to help you in the future to reproduce the process. So let's start now. I am Jerome Etienne. I do Three.js, WebGL, this kind of stuff. And today I'm going to do a flying spaceship game with you in less than 1 hour. And I don't remember the amount of lines, but it's less than 300 lines to code this stuff. So let's do that. First, what we're going to do, we're going to do a mini game called Flying Spaceship. It is all inside the browser. It is Three.js to get the 3D. It is quite important. This is WebAudio to get the sound. WebAudio API is, how can I say? Well, it's an API which is a standard. It has been adopted by Safari, iOS, Google, Chrome, obviously, and Mozilla. So it's everywhere. When you need audio, you can use WebAudio API if you need WebGL. I'm not sure you understand all that, but if you have WebGL, you have WebAudio API. This is the important part for you guys. So first, on a bit cheating here, let's see what we're gonna build. So you got a small spaceship here. We go up and down. I'm touching the keyboard to go up and down. You got some planet going around. And when you go inside the planet, you destroy the planet. This is not much, but this is what we're gonna build together in less than an hour. One last bind. Bang. Okay. So there's a lot of bang. Expected final rise. That's this one. So for this one, we're gonna build various steps. First one is Three.js boilerplate. After that, the boilerplate is basically, I'm gonna explain all those steps, right? It's more to keep you reassured. Then we're gonna do a spaceship. Then we move the spaceship via the keyboard. Then we add the planet on the stars. Then we have the collision. Then we add the sun. Seems simple at first, but at the end, there is various steps to follow, right? Okay, so let's get started. First thing, we need to install the Three.js boilerplate. So first, what is the Three.js boilerplate? So Three.js is a library in which you do 3D and you display it in various ways, mostly WebGL. And the boilerplate is basically, to start this, you need a lot of things, not that much, but quite a bit, maybe 150 lines of JavaScript. And I did something called the Three.js boilerplate to get you started with the best practice already set up. It is tunable through Yeoman. Let me start that for you guys. Okay, so this was my up. This was when I repeated. So first, let me remove my repeat step. Like that. So now, let's go. We have Three.js plus Yeoman. Yeoman is interesting because this is an effort by Google, and it allows you to generate things for you which you don't have to repeat. It's super important because when you are a beginner, very simple step seems hard. And to have something to set you up since the beginning is very helpful. So for that, we use Yeoman. It is interesting, but it is not required. Very important. You can use Yeoman with the tools Yo to generate the boilerplate, and after that you can include package with Bow. We're gonna see how to do all that. When you have the slide, you see you have grunt Yo on Yeoman. Up. So you have grunt here, you have Yo, which is a Yeoman usual generation package. It was working well. Alors, so the first step is we're gonna create a directory called Flying Spaceship. Up to you to create whatever name you want, right? Let's try to do this one. As soon as I can do a cut paste, let me try again. Up. Okay, so mkdir Flying Spaceship. Then we go in the Flying Spaceship directory. We are inside the Flyship directory. Now we're gonna generate the boilerplate with Yeoman using Yo Three.js boilerplate. Very simple stuff. Yo Three.js boilerplate. Enter. He asks you a bunch of questions. Not that big. Is basically say yes if you don't know what you are doing. If you want to fine-tune or highly optimize your boilerplate, you can answer a question. It's not that relevant right now. So, you have this directory which has been generated. What is interesting here is you go in this directory, you do make server. Make server gonna do what? It's gonna launch this wonderful command just there, Python minus simple HTTP server. This stuff doesn't do much. It's just launch an HTTP static server on your files. That means that those files, index HTML, border, all that. Can you cut the microphone? That would be great for whoever did the noise. Okay, let's go on. So we serve the simple HTTP server. This way, all your files, this stuff that has just been generated, gonna be served over the web. Let's see what we have generated. We have done the make server here. Now we do the generation. Let me do it live on my local. So what we have just generated by the boilerplate, what you are seeing right now on the screen is the boilerplate of Three.js. That means that doesn't do much, that's just a cube running around in your web browser. But you have initialized all the repetitive things, all the stuff that you don't want to reinitialize all the time. So you have a cube running around. That's not that much, but that's WebGL. That's do a lot of things. And this is a boilerplate. Let me kill this one. one, not the Hangout. Let me secure this one later. Oops, là, okay. So we have the result. So we add a simple, very simple cube running around on the screen. Now, to start, we need to add some spaceship, right? This is a game. This is a game where you move some spaceship into space. So first, we're going to use something, an extension, which is called 3x Spaceship. You got it from 3x extension. You install it with Bower, or you get it directly on GitHub. Bower is, how can I say, it's like NPM for the web. I hope you know node.js. This way NPM ring a bell. But it's very simple to install. So you take this symbol line, Bower install 3x Spaceship. You go inside the directory you just created. We are here. We pass this command. We press enter. It's installing. Wonderful. As you can see here, we have makefile, index, on vendor. If I do it again, we have one new repository, which is called Bower component. Bower component gonna contain all the Bower component, I guess, package that you have installed. And inside those Bower component, you have something obviously super interesting, which is 3x Spaceship. That's what we just did. But one question comes just there is, what is 3x? So 3x, what is that? It's a bit, it's an ultralight extension system for Three.js. What I mean by ultralight is meaning by you have no dependency besides Three.js. This is a Three.js game extension, so the page for 3x, and you have at the moment 44 3x extension. You have like this one. So that's one of them, right? So what is this guy doing? Yeah. Okay, let me remember. We're gonna stand, run. This guy gonna run. Yeah, run for me, baby. You can change the weapon. That's one of them, right? There is 44 of them. You can change. That's a system to do extension for Three.js. So this one is about doing some Doom characters with all the animations that you got. You see, it's going crazy. Where's the head? I don't remember. Okay. There's some Pac-Man, some Grace, some text, there's a lot of them. There's some spaceship. We're going to use this one, the spaceship. Let me show you the spaceship just for the fun. So this is 3x Spaceship. We're going to use this one because we need a spaceship in order to destroy a planet. So you have 5 spaceships which are available. You have some shooting stuff. All that is open source. You can reuse that in your own game. This is quite important for me. Let me find the other one we're going to use. This is the planets. This one is the planets. Very important, planets. Planets we're going to use. So, for example, this is an example of planets. You got the Earth. You got some moon here. You got some shadow casting. And some atmosphere. I'm not sure you see it through the broadcast, but there's some atmosphere shadow here all around. Okay, all that. This extension is quite interesting because you let's say, I have done all the other planet of the solar system. So this guy is Uranus. I'm not sure to pronounce that in English. Uranus. I'm not sure, but you got the ring, you got the shadow casting, everything. Once again, all that is a multi-license, guys. So you can do whatever you want with it. Okay, so this was the topo on what is 3x game extension. So 3x module are working with Require.js. Require.js is a project which allow you to easily load all the dependency of your stuff on various other things, which are quite useful if you know how to handle it. But as usual, when I do game extension for Three.js, I do it optional. So you can use it if you want, you don't have to use it if you don't want to. But if you do, that's faster to develop. Believe me, my past job was to do video game developers, CTO of a game developer company, to be clear. So you included the spaceship in your code, in the Require.js. After that, you include the spaceship. Now, let's do that first. Let's do some realistic stuff. So we have done Three.js boilerplate. Now we're gonna install the spaceship in itself. If I succeed my cut paste, cut, paste working, excellent. So it's installing spaceship. Excellent. We are here. Now we have done the 3x. Let's change the border in order to include all that. We go inside the HTML. Here, what we have, the index HTML that you see here, is the boilerplate which has been generated. So you got some script, some doc type, here Require.js installation, all the boilerplate that you can use here. Now, let's pass what we have done. Okay, not this one. This one maybe. Excellent. So we passed. So I do that with you guys, meaning that you can do it at home as well. If I succeed, okay. Live demonstration is a bit awkward all the time. So we have included in the Require.js all the stuff needed to load the spaceship. Now we're gonna build the spaceship. So to add the spaceship, first off, you need to do this wonderful command. Let me zoom my stuff here. You need to do 3x spaceship load spaceship 3. And after that, you got a callback, which is going to be code. You add that to your scene, and that's over. You got your spaceship. Let's do it. Let's do it. So we got something like that. We had a wonderful comment like spaceship. Excellent. We passed our code. We do some indentation because we are nice guys. Tick, 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 tick. Okay. Let's rerun our wonderful demonstration. So it doesn't seem much, but in fact, inside this wonderful cube, there is our spaceship. The next stage here is to remove the spaceship because, as you can see, the spaceship is inside the cube. So we remove the cube. This code is doing the cube stuff. We remove the cube. We relaunch. We relaunch. It doesn't work. I made something silly. Something super silly. Where is this mistake? Just there. I made something silly mistake. What mistake I have done? Oh yeah, I have done this mistake. And suddenly we have our wonderful spaceship. That's live demonstration, guys. Okay, so we have our wonderful spaceship here moving around after 21 minutes already. So we remove the cube. We have our wonderful demo. The next stage right now is, as we have our spaceship, we need to control the spaceship. Let's control the spaceship with a keyboard. So to do the keyboard, we're going to use something called 3x keyboard state. It keeps the current state of the keyboard. That's a 3x model for Three.js. It is available on GitHub as usual. So you have wonderful GitHub stuff. MIT license. You can use it without trouble. There is even a blog post explaining everything in Learning Three.js. By the way, that's my blog. If you want to do more about Three.js, that's a good place to start. So blah, blah, blah. Keyboard stuff. So first stage, let's install this keyboard state. Once again, it is a variable bower install React keyboard state. We go here. We do bower install. It's installing live. Fast enough. And after that, you need to load this stuff. So you need to add this line inside the require.js. You go here, put a comma, you pass that. You reload in order to be sure you are okay. No 404, nothing like that. Everything is cool. So to control the player with the keyboard is surprisingly not as simple as it seems. First, you need to add a function in the rendering loop. This function gonna do a monitor of the keyboard state and move the spaceship accordingly. There is some pitfalls that you have to take care of. First, the loading of the spaceship, of the model that you are doing, is asynchronous, meaning that you launch your page, and this is not because you launch your page that the model is already loaded. You need to wait a bit. It seems automatic like that because I am over localhost. But it takes some time. It takes sometimes like half a second, but you need to actually wait. And after that, you need to be sure that the speed of the spaceship is independent of your frame per second. Let me explain this one. If you have a slow computer and your speed is not independent of the frame per second, this is trouble because you have a slow computer. This way you have, I don't know, maybe 10 frames per second. And if I move per frame, your stuff gonna move at 10 frames per second. On a fast computer, you're gonna move at 60 frames per second. So 6 times faster. Suddenly, your spaceship gonna move 6 times faster. That's gonna change your gameplay quite a bit. It is very important to be independent of the performance of the computer when it comes on gameplay. Trust me on that, let's say. Okay, so now what we have said, all that, this is the implementation that we're going to do. So first, we create the keyboard instance with this simple line here. var keyboard new React keyboard state. Nothing too challenging here. We add a function in the rendering loop. Our rendering loop is simply an array of functions. On render function, push function. So as you can imagine, on render function here is just an array. Okay, nothing worse than that. Very simple stuff. So this function that you see here gonna be launched, let's say 60 times per second on average. And you got with wonderful command. Let's put that in our code and see how it goes. We go here, spaceship. We go here, we do pass. We do something like that. Here, we come here, and we do keyboard control, let's say. Okay. Just wondering, where are you guys? So everybody there? Somebody moving for me, just to be sure I'm not alone. Okay, somebody is moving. Okay, thanks guys. Okay, so we have passed this code for keyboard control. So the keyboard control is there. This is the code which has been passed. We reload, and suddenly, you have to trust me, but I press up and down, and suddenly the small spaceship is going up and down. It's not that complex, right? let's look a bit at this code. Here we initialize a keyboard. Here we say if keyboard pressed down, then spaceship position Y, so the position Y meaning you're going down, is going by this amount. If you press up, it is plus this amount. If you press down, that's minus this amount. That simple. You can tune the speed here. Just for the point, let's put 2. So this is the original speed. So you see it's moving at this speed. I reload. Now it's going to move twice faster. You can tune that to your own liking, guys. That's simple stuff. Okay, so now we have a wonderful spaceship. It's moving up and down. This is very simple. Okay, so now let's add some planets. We need some planets to go through, to go inside us. This way we can destroy it. So first stage is we're going to use 3x planet. Let's look at this. One's going to be enough. So your demo here is, so 3x planet is a 3.js extension, which is done for 3.js, obvious 3.js extension for 3.js, yes, silly me. And this extension allows you to easily build all the planets of the solar system. So I did a small demo just there where you have our, let's say, planets, the Earth, some cloud. I don't know if you see, but the cloud are moving. You got some mountain on the Earth. You got the moon, everything like that. It's looking rather cool. And as usual, all that is MIT, open source, available on GitHub. Be sure. Okay. So there's even a blog post as usual, usually by Learning 3.js blog, blah, 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 where I explain all how to do the planet. I provide an easy extension, but I explain all the detail if you want to. Blah, 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 blah. And you got all the planet around. Very important. Let's see what else I got. Ah, yeah, the demo. Oops, my bad. I killed my slide, guys. 2 minutes before I come back on my slides. Diggy, 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 dicks. I'm back on my slides. Excellent. My bad. Excellent. So we are back on the slides. On here, you can, just to show all the possible extension, you got here, you got Uranus, Saturn, usual stuff, Neptune, Mars. Mars is a bit longer to load. I don't know, Mercury, Pluto. Pluto is not supposed to be a planet, apparently. People are emailing me that now. It's not that important, but okay. All those textures are coming from a guy called Planet Pixel Emporium. I took all the texture from him. It's open source, so that's okay. I'm allowed to do so. If the guy still is online, come on, load for me. Okay, it's loading. It doesn't seem to load that much, but okay. Apparently, the guy got some internet problem. Okay, let's not waste more time on this one. That's Planet Pixel Emporium. A cool guy doing some interesting things when it comes to space visualization. So, in our case, we want to have 3x planet with Bower. So first step, Bower install 3x planet. Not too hard, right? We do Bower install 3x planet. He's doing his things. He's installed now. Pretty cool. Everything is inside Bower 3x planet. Let's look at that. ls-l Bower. On here, you got 3x planets. This has just been installed with Bower. That's pretty nice. Rather simple. Now, we load it with require.js. First, require.js call inside the header and put that. So we put this wonderful line here in require.js. We go here, we install a command, we put that require.js. So we have done keyboard state. Now we do planets. Not that it's gonna do anything, but at least it is loaded, right? So now that we have loaded the 3x planet, let's add some moon. So var moon mesh. So the command that you want to do for the moon is this one: 3x planet create moon. It is very simple stuff which creates a sphere and applies the texture of the moon. 3x is a lot about very simple extension that you can reuse, that's the main purpose, or you can use for educational purpose. That means you come, you don't want to reuse 3x planet create moon, or you want to use another texture for the moon or whatever like that. You go to see this function and you can easily learn from it. This is important. There is a lot of educational purpose in 3x. So camera control, let me put some moon here. C'est pas, so moon, that's it. Oops, we pass this. So what we do here is we create a moon and we add it to the scene. This is that simple, believe it or not. Up, we go here and we reload. So we reload is, you can still see the wings of my spaceship, but there is a moon in the middle, right? But still have the moon, right? So as you see here, it's a bit of a crowded. So now what we need to do is, inside to have the spaceship inside the moon, we need to put it a bit on the left. We're gonna use this code here. So we take our spaceship, we rotate that along the y-axis of half of a quarter, I'm not sure, p divided by 2, and you do x minus y. So let's take this code. Here we go, it's this part. We pass the code. I said, okay. And suddenly, our demonstration become a bit better. And we still have the keyboard control, right? So we have our moon, we have our spaceship going up and down. It's pretty simple stuff. Now we need to make the moon move. Because let's not forget, the moon is supposed to move against the spaceship, and when the spaceship is touching the moon is supposed to explode or something. So first stage will be to set up the initial position of this moon. So we do a function reset moon on moon mesh. So the mesh that we have created, just let me find it again. Where's my moon? Give me my moon. Moon mesh. We have created the moon mesh. We have added that to the seed. Now we want to set the initial position of the moon. In the middle of the screen is not proper, right? So we add a function reset moon and we call this function. This is very simple. We can paste this. We passed here. Okay, something like that. We do some indentation because I'm a nice guy. Hop. Where is my moon? Every time I load, you see there is a moon far away. The moon is placed there. Okay, so now we have the moon. We have the initial position of the moon. We need to make the moon move. So for that, we animate the moon, and under the limits. Just below, very simple, tick, 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 hop. We have the wonderful code. We put that inside the rendering loop, make it move with this wonderful subtraction. We make the moon moves to the left, and after that, when the moon has reached a given level, we'll reset the moon again. Let's try. First, as you can see, the moon is moving now. It's that simple. And when the moon is going too far, it's disappearing and coming back on the front. Yopla. And the issue here is the collision is not yet made, right? See, if I put this spaceship is going through it, that's not too good, right? Let's do something about it. First, let's add some decorum. We need to add some stars. So stars are something funky, which is an environmental sphere. That means that a very big sphere on which you put an image of stars. It is that simple. This is the image of stars that you see here. Just a lot of dots on a black. Next slides. So, first stage, you need to create the geometry of the sphere. Hop, let me create that. You create the geometry of the sphere. Okay. Now, you need to create the material. So the geometry is the shape of what you're going to do. And after that, the material is how it's going to reflect the light. It's supposed to work something like that, I believe. Let's try. And after that, once you have the shape on the way to reflect light, you create the object itself, which we call a mesh. If you do 3D, there is a lot of strange terms like that, like a mesh. Don't be too scared about it. That's only synonymous stuff. You can easily ignore it, in fact. So, as you can see, we have copied this code here. And now we have, let me remove this debugger here. We have star all around. That's a lot better, right? When you have star all around, you seems like you are in space. Before, no star. See the difference, right? It seems like, I don't know, doesn't seem like space. So you need to add some context for people. People expect spaceship to be in space. So you put some stars. We have added the stars, but still we go through our moon. That's not too cool. So for that, we need to add collision. The collision for gameplay is we want the spaceship to destroy the moons. And if your spaceship is going through the moon, it's going to destroy the moon. That's what we want to do. So the algorithm is very simple. If the distance between the spaceship and the moon, so the distance between this guy and this other guy here, is below 3, less than 3, then we're going to do a contact. And if there is a contact, we reset the moon position. There is some pitfall, like you need to be sure you handle the asynchronous model loading and the fact that the spaceship is not spheric. So you simply need to use this small line here inside the code. We go here, let me remember where it is. Spaceship, nowhere. Up, I take the word code. We got the moon, we got the stars, we got the spaceship here. I pass this code here of the collision. So I pass this code directly from the slides. I reload the examples. I put my object jet here. And as you can see, the moon is disappearing. So supposedly I destroyed it. If you do an actual game, you probably want to do some explosion or stuff like that, but time is missing for us. Okay, so time is disappearing. To add some realism, we need to add some sound. So let's make some noise. To make some noise, as I said, we're going to do WebAudio API. WebAudio API is very interesting because this is a low latency sound API for games. This is available on all the platform for which you got WebGL. This is very interesting because WebAudio API has many other advantages, but one advantage is you got something called sound spatialization, meaning that if your sound is on the left, you're gonna hear it on the left. If your sound is behind you or above you, you're gonna hear it behind you or above you. Sound localization is very good for immersion, for the player to feel inside the game is very important. So for that we have some library called WebAudioX. That's just a bunch of helper, heavily documented. So we go here. Once again, it's MIT. It's MIT license, so you can reuse for basically anything. You got a lot of documentation, blah 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 blah. A lot of example as well. And that's WebAudioX. You can take explosion sound from Freesound. Freesound is interesting. Let me go there. That's a library of sound which you can reuse under free license. That's pretty cool. So let's install this one. Bower install WebAudioX. Usual stuff, right? We are in the simple. We install WebAudioX. It's installing. Today it's installed now. Excellent. Installed now. As you can see here, it is installed. So now we need to include it in our web application with this wonderful line, the require.js. We go here, comma, space. This is included, just like that. And you see, it's like less than a minute to do it, right? So now that we have included it, we need to initialize it. Initialize web audio. So let's try to do that. We go at the end, let's say here. We put Codementor because I'm super nice. We initialize the audio contact just there. This line is the volume. So you put whatever number you want, right? I put 0.2. It's up to you to put your own. And after that, you need to load the sound. So this is going to load the sound. So this wonderful URL here, blah, 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 is coming from Freesound. And up to you to find the one you want, right? For now, I'm going to take it directly from my slides, which are there. So let me here. So I copy it. Take it from my slides, that's no trouble. So we do mget sound. And after that, we move the file here, sound. A wonderful sound here inside this directory. We got our code here, which gonna load it. We're gonna try to reload in order to be sure there is no mistake I made. And everything is going cool. But we have done only the initialization, right? So that's not good enough. We need to actually play the sound. This is gonna play the sound. Function to play. Just below, we pass the function to play. We pass the function to play. Now, we need something to play the sound on contact. So it's pretty simple. We have done, if there is contact, we reset the mood. We have already done that, guys. So you see, you go here. If there is contact, poof, I reset the mood. If there is contact, poof, I reset the mood. So now, instead of just resetting the mood, I play the explosion sound. This function I created just there. I play the explosion sound. Where do I play this? Reset mood here, I guess. And My keyboard is causing trouble to me. Oops. So, if the no, that's not the proper place. My bad, guys. Let me reset. Up. Pretty close, right? This is the air. So compute the distance between the spaceship and the moon. If the distance is less than this, place the expression and reset the moon. Let's try this one. We got the moon here. I hope you heard. Wonderful sound we got here. One last. Excellent. And believe it or not, we still have time for a question. This is the end of my presentation. This was a small game that we can do in less than 48 minutes while talking, so that's live coding. If you do it at home, you probably spend less. And I guess I'm available for question. What do you think, Wayne?
Sure, yeah, awesome. Let's open the floors up. And guys, do you guys have any questions for Jerome?
Or not?
Yeah, so
yes.
I was wondering, it seemed like it was hitting the moon early. How would you make it so that as soon as it touches it, it would initiate the sound? Would you have to change the coordinates around? What would you have to do?
As soon, yeah, because right now you seem to see that the moon is entering inside the spaceship, and then you got a sound. Is that what you're saying, me?
Yeah.
Okay. It's just that because of the lack of time, I do a very simple collision system. And this collision system is based on sphere. So sphere with my hand is not that simple. But the spaceship, as you can see, let me do a wonderful spaceship. This spaceship, for example, is not at all spheric, right? So if you want it directly much better, you can do that with B-box. Boundary box is you compute the box encapsulating, let's say, the spaceship, the box encapsulating the moon, or you compute your intersection. Inside, all that is inside Three.js. But you compute the two, and this way, it's gonna, as soon as you got contact, it's gonna trigger the impact versus the sound. Does this answer the question?
Yeah, that answers it. Thank you.
Okay, pleasure. Another questions? Whatever, guys.
Any other questions?
Yeah, in the beginning you mentioned that depending upon the computer that you're running WebGL at,
Yes.
you see different speeds. Is there a way to show your frame rate for this demo?
Sure, there is many ways to do that. There is one way which is called, which is super usual in Three.js, which is stat, which is super well known. Let me put like any example of Three.js. This guy has removed it everywhere. There is usually a small blue stuff here. FPS, you can use various example of the on Chrome. You can display the FPS directly on screen. Let me remember how to do that. The pre-flags. About slash, do you see, no, you don't see my screen right now. Let me put my screen. That's going to be much easier for you guys. Oops, something like that. Start screen share, much better. So you do in Chrome flags. Here you do FPS maybe. FPS counter, yes.
Um, I think Jerome just dropped off.
Yeah.
Yeah, let's wait. Maybe he got internet disconnected. Let's wait for him a little bit.
Okay.
Are you still here, guys?
Yes.
Yes, Jerome, you're back.
I'm sorry. To add the option, I had to reboot Chrome on silly me. I didn't realize that's gonna cut the communication.
Yeah, I got it.
So we are back. So you see, meanwhile, I did this. So you see this FPS counter here? You do FPS counter, and I did enable. So this way, when you go on anything WebGL, you're gonna use this FPS here, FPS stuff. Okay, so my computer is pretty powerful, so there is no trouble about that. If you go in our demonstration here, you got a demonstration. The game that I did for you guys is really low WebGL. Low WebGL, meaning most computer, desktop computer, and okay, Shuba is still doing noise. And mobile computer are able to run this stuff without any trouble. Most games are currently today, as you can see on console or serious games, they use much more WebGL than the game I did. Performance is actual. When you do performance on WebGL game, this is not simple stuff. You need to have actual experienced people to do that. That's not a simple topic, especially when you want to port on mobile. Recently, not that recently, but we have Android for a long while able to do WebGL. iOS has announced WebGL very recently, like I don't know. Why is there this? You still hear me? Yes, no. Sorry, I'm killing this. Sorry. Oh, do you still hear me? I guess. What else I can say? iOS is available. Safari got it on Mac OS 6 now, and you got it on Microsoft, and you got it on Chrome as well, and obviously Firefox OS. So all the big players got it now. So that's a major step for WebGL. Very major step. Any other questions?
Nope.
Any other questions, guys?
Guys, don't hesitate. I'm there for this.
I guess we're all good now.
Oh, well, good. Okay.
So yeah, thank you so much, guys, for coming, and thank you so much, Jerome. Really appreciate the great help.
Thanks a lot.
Thank you.
Thanks.
Thank
Oh,
you.
yeah, thank you. So let's take care.
All right. Bye.
Take care.
See ya, everybody.
Thanks, Jerome.
3, 2, 1.